Morning children. So you all have seen the video which we have uploaded yesterday. You all know we have started with topic of chapter 13, fun with magnets. Before we start, we go to the next topic. Let's have a quick recap of the topic which you have seen in the video which we have uploaded. You know children, a magnet is a material which attracts iron pieces towards itself. You also know that magnets are of two types, artificial magnet and natural magnet. When we say natural magnet, we mean the magnet which occur naturally. Now, if they occur naturally, they don't have a proper shape. They are irregular. They are oxides of iron. And you know that one natural magnet, black ore, that is Fe2O3, that is also known as black rock or lodestone, and it is used in ancient time by the sailors to find the direction. Now when we compare this natural magnet with artificial magnet, since they are man-made, they have a proper shape. They can be bar magnet, they can be dumbbell magnet. Now, and when we compare the magnetic strength, artificial magnet are more strong than a natural magnet. Now children, this is a pair of bar magnet. What is a bar magnet? Because the shape is just like a bar. Now I am going to show you one experiment. Here I have some iron pins. Now see what I am doing. Now see children. Most of the iron pins, they are attracted towards one end of the magnet. So these two ends where most of the magnetic power lies, these two ends are called the poles of a magnet. So now we begin with the first topic, poles of a magnet. What are the poles? The poles are actually the two ends of a magnet. And what is so special about these two ends? These two ends have got the maximum magnetic power. That is, maximum magnetic strength is at the two ends of a magnet. Now, how do we represent these two ends? We use two alphabets, N for North Pole and S for South Pole. So a magnet which has two ends, these two ends have got the maximum magnetic strength. These two ends are called the poles of a magnet. We denote them as N for the North Pole, S for the South Pole. Now children, let us see what are the properties of poles of a magnet. Now, remember one thing. If you break this magnet, then also the smallest piece which you have will have two poles. It is not possible to get a magnet which has only one pole. So we say that poles are two in number. Poles are two in number. That's why we call them as dipole. It is not at all possible to get a magnet which has only one pole. You keep on breaking a magnet. The smallest piece which you will get, that smallest piece will also have two poles. It is not possible to isolate the two poles. It is impossible to isolate poles. That means we can never get a magnet which has which has only one pole, because these poles always exist in pairs. I hope definition and properties of poles of a magnet clear to you. Coming to definition again, what are the poles of a magnet? The two ends of a magnet where magnetic strength is found. How we denote them? By two capital letter, N for North Pole, S for South Pole. These are two in number, that means poles are in pair. Since there are two poles, we call it as dipole. Di stands for two. It is impossible to get a magnet which has only one pole. That means these poles can never be isolated. They are always present in pair. Now children, coming to the next property, one of the common property of a magnet, you all know that it attracts iron pieces, but there are two more properties of a magnet which we are going to cover today. And what are these two properties? First one, attractive property. And directive property. Now coming to attractive property. Look here children. Now see, this white dot in this magnet represent the North Pole. Unmarked represent the South Pole. Now see what I am doing. I am bringing this South Pole towards the South Pole of another magnet. Now see what happens. Okay, are they being attracted? No. So what is happening? The two magnets are trying to move away from each other. Now let us try with North Pole, and here North Pole. Now what is happening? Again the two magnets are trying to move away from each other. But the moment I turn this magnet a little bit and bring South Pole towards the North Pole, see what happens? As you can see that they have attracted. So when we talk about attractive property, we say that same poles repel. And when we talk about unlike poles, they attract. For example, if I bring North Pole of one magnet towards North Pole of another magnet, as we have done in the experiment, you know that the two magnets will try to move from each other, or we say that repulsion occurs. On the other hand, same thing happens if you bring South Pole of one magnet towards South Pole of another magnet, then also repulsion occurs as they are similar poles. Repulsion occurs as they are similar poles. Now, on the other hand, if we bring North Pole of one magnet towards South Pole of another magnet, you find that the two magnets attract each other. That is, attraction takes place. Or if you bring South Pole of the first to the North Pole of the next magnet, you find that attraction takes place. So we can conclude from this that similar poles always repel each other, or you say that like poles always repel each other, whereas unlike poles or dissimilar poles attract each other. This property is called the attractive property of a magnet. Now coming to the directive property of a magnet. Now when you suspend a freely suspended magnet, always point in the north and south direction. This property of the magnet is known as a directive property of a magnet. So let us see this also. What is this directive property of a magnet? A freely suspended magnet always points in north-south direction. This is the directive property of a magnet. Same property is used by sailors to find out the direction and same property is used in magnetic compass, with which you can find out the direction, and we will be continuing with magnetic compass in our next class. Chapter 13, Fun with Magnets. And in this PPT, we are going to cover the following topics. 1. Poles of a magnet. 2nd, properties of a magnet. 3rd one, attractive property of a magnet and directive property of a magnet. Coming to poles of a magnet. What are these poles? The two ends of a magnet where magnetic power is maximum. These are denoted by capital letter N, which stands for North Pole, and S, which stands for South Pole. Poles are two in number. Poles always exist in pair. That's why since they are two in number, we say that poles are dipole. Poles cannot be separated. It is not possible to isolate North Pole from South Pole. It is impossible to get a magnet which has only one pole. So again, what are the poles of a magnet? The two ends of a magnet where magnetic power is maximum. These two are denoted by capital letter N, which is the North Pole, and capital letter S, which stands for South Pole. These poles are two in number. These poles always exist in pair. Since they are two in number, we call it dipole. They cannot be separated. That means poles cannot be separated. It is not possible to isolate North Pole from South Pole. We can never get a magnet which has only one pole. Whatever small the size of a magnet, it will always have two poles. This suggests that poles always stay together. It is impossible to separate North Pole from a South Pole. Now here you can see that the red one where it is written capital N shows the North Pole and the blue one shows the South Pole. In the first one we have bar magnet. The second one we have U-shaped magnet. Whatever may be the shape of a magnet, it is impossible to get a magnet which has only one pole. Coming to the properties of a magnet. First one, attractive property. Second one, directive property. Now, attractive property, a magnet attracts iron pieces towards itself. This property of magnet is called attractive property. Directive property, a freely suspended magnet always points in north-south direction. Once north-south direction is known to us, we can find out the other two direction. This property of magnet is used in making magnetic compass. As you all know, we use a magnetic compass to find out direction. So again, what is attractive property? A magnet attracts iron pieces towards itself. This property is called attractive property. Then there is a directive property. A freely suspended magnet always points in north-south direction. This property is used in making magnetic compass, which is used to find out direction. Let us see how does this attraction and repulsion takes place in a magnet. Now remember, in a magnet, same poles or similar poles or the like poles, they always repel each other. Whereas opposite poles or dissimilar poles, they always attract each other. So if you bring north pole of one magnet to the north pole of other magnet, repulsion will take place. Or if you bring south pole of one magnet to south pole of other magnet, then also repulsion takes place since they are similar or same poles. But if you bring south pole of one magnet towards north pole of other magnet, attraction takes place. Or if you bring north pole of one to the south of other, then also attraction takes place. This suggests that same poles or similar poles repel each other, whereas opposite poles or dissimilar poles always attract each other. Coming to the directive property of a magnet,
लम्बा कर दिया